Why, hello there, lovely ones. So we are going to look at how to find derivatives using the first principles. And your question will tell you to use first principles to do it. These questions are taken from the Mind Action Series textbook, grade 12, chapter 4, and exercise 2, on page 91. And I've just chosen a couple of them to help. This kind of thing really is just practice and practice. And so once you know how to do it, it's all good. So we're going to start by writing in the information. So we know that it's going to be lim, and then underneath it, h tends towards 0, and then we've got this fraction bar. The first term is going to be this equation over here, but instead of x, we're doing x plus h squared minus 3. Then the second term is just going to be normal f of x, which is going to be x squared minus 3. And of course, at the bottom, it's going to just be h. Now our process is to then do all the multiplying out and stuff. So let's go ahead and do that. Now that we've got to this point, we're now going to take out our common factor, and we will always have a common factor of h. And so that leaves us with 2x plus h over here, and then we're dividing by h, and of course that means that this is our derivative. It's still going on. And then we substitute 0 in for h, and that gives us 2x as our first derivative. Question 5 is a lot more interesting because we've got 2 x's happening. So just to remind myself that this is what we're doing, I'm writing down all of this, so that I don't have to keep scrolling up to see the method we're using. So we know that it's going to be f of x plus h, and it's going to minus f of x, and that is of course over h. So now I am going to substitute that in. So I've got g of x, wasn't the first derivative. Okay, and let's say the limit is h is tending towards 0. This is going to become a bit of a mess. So I'm going to give myself a lot of space. And that first one, this f of x plus h, I'm going to do in yellow so that it's just easier to see. I have got minus, and then instead of x, I'm putting x plus h, and it's squared, and then I've got plus 3, and once again it's going to be x plus h instead of just normal x. Then let's do the second one in green, just so that once again it's easier to see. We've got minus x squared plus 3x, and of course at the bottom we still have h. So at this point I'm going to add my like terms, and that is going to leave me with negative 2hx minus h squared plus 3h. I suppose I didn't need all of this space over here, so let's erase it. Okay, then once again, we know that we have to take out a common factor. It's just always part of the process. So we're going to do that, carry on writing that h tends towards 0 until I've actually finished the last thing. So our common factor is going to be h, which leaves me with negative 2x minus h to the power of 1 plus 3, and that's all over h. And that of course means that I am left with, if I were to cancel them, which I'm going to, I'm left with negative 2x minus h plus 3. The last step is to recognize the fact that we're throwing in 0 for h, even though it can't be 0, but that's why we say the limit extends to 0. And there we go, we found the first derivative of this function.
And now for question C. So as you can see, we're talking about the first derivative of g of x, and we're going to start by putting in the information. Remember that when you're rewriting it, you need to fill in all of, well, write down everything. Don't forget to write down the limit, so h tends towards 0, and then, of course, we substitute wherever we had x, over there in the denominator, we've now got to substitute x plus h. And as we can see, we've got two different denominators, which means we need to find a common denominator. And in this case, it's going to be x times x plus h in brackets, as put down in this next line. We're still dividing by h, but you'll see in the next line, I'm going to change it to, well, dividing by h and then change it to a multiply. Now that we've got the reciprocal, we can then cancel as we would with negative 8h cancels with 8, and we're left with negative 8 over, and I've also multiplied out the brackets so that I've got x squared plus xh. Now that we've done that, we can say that the limit of h is 0, and that would be our first derivative. The next question asks us to calculate the value of first derivative when x is equals to 1, so we're just going to substitute that in. This, of course, gives us an answer of negative 8. The next question is quite interesting. So it says, explain what your answer in question 2 means. Let's just go over it again. We've found the value of x when the first derivative is equals to 1, and we said it was equals to negative 8. What that means is at the tangent that is at, I'm not actually going to write it all down, but the tangent that is at the point where x is equals to 1, the gradient of that tangent is going to be negative 8. So if the first derivative is the formula to find the gradient of tangent at any point, when they say at which values of x is the gradient of the tangent equal to negative 2, it means that they're wanting us to take the value of negative 2 and substitute it into the equation and then solve for x. So I'm going to multiply both sides by x squared and then move that over there so that I've now got x squared is equals 2, and that divides, so that's going to be 4, which means x is going to be equal to plus or minus 4. So just to recap what that means, it means that when our function, our original function, is at the point where x is plus 4, or at the point where x is minus 4, the tangent to that function, the gradient of it, is going to be negative 2. Okay, the last question is also, it's a really nice question because it asks if you understand what you're saying, and that says, state whether the following statement is true or false and motivate your answer. The gradient of any tangent to g is negative. So we know that the gradient is defined by the first derivative, and we also know that the first derivative was negative 8 over x squared. Now negative 8 is always going to be negative. Yeah, because, well, negative 8 is always negative. It's a constant. Any number that's squared, even if x was negative 3 squared, it's still going to give a positive. What do we know about a negative number that is always divided by a positive number? You're always going to get negative as an answer, which means this statement is true. And it's true because, well, negative 8, the constant, is always going to be negative, and any squared number is always going to be positive. Positive divided by a negative number is always going to give a negative answer. And that's it for this exercise. Much love.